You've already looked at the main XJE's keywords and how XJE's code is structured. This time, you'll see how to call functions that reside in other files and some useful library functions you might want to use. It's quite common for more than one test device file to need the same function. For instance, files for I2C devices need to use code that implements the I2C protocol so they can use the bus. Rather than putting that code into every test device file that needs it, it's better to create a set of common functions that the test device files can then access. Those shared functions are stored in what XJTAG calls additional code files, and there are lots already in the library, including one to control the I2C bus. You'll see some of those later, but first, let's look at how to call them from your code. There are 3 things you need to do in your test device file. The first is to add a reference to the additional code file that has the function you want to use. That will automatically add any buses needed by the additional code file, but you'll have to provide their PIN numbers. Finally, you may have to set up some constants or configuration variables for the function you're calling. Let's look at those 3 points in turn. You saw in a previous video in this series how to create a test device file, so we'll start from the basic file you saw being created. Additional code files are then added to the file in this tab. Click Add and select an option from the menu. You can take a file from a library, either your own library or the XJTAG one, or you can browse to a file if it's saved elsewhere. Let's take the example of a test device file for a SPI device. If you were working with one of these, you could go to the XJTAG library to choose the spy.xje additional code file. Find the file and click Select. XJDeveloper will then put a copy of that file into your project directory and add a reference to it in the test device file. You should then save the updated test device file. Note that it's this button here in the test device file editor that saves it, not the one in XJDeveloper's toolbar, which is for the complete project. If the additional code file needs some buses to be created, the system will add them automatically, and you'll be shown what has been created. Once the test device file has been saved, you'll also see the additional code file listed in the Navigator pane on the left. You can add more files if needed, and they'll then be parsed in the order they appear. If you add an additional code file from the library that uses functions from other additional code files, the other files will be added automatically and in the required order. If you want to see what functions are available in an additional code file, you can do so once it's been added to the project. Double-click the file to open it and use the Function button at the bottom. That gives you a list of what you can use. Click on a function, and its code will be displayed. An additional code file will use bus names that it has defined. For instance, this protocol file for SPI calls the buses SClock, SDIN, and SDOut. To ensure the bus names are the same as those in your test device file, XJDeveloper will automatically add buses with those names into the test device file for you, but will mark the pins as not yet configured. You'll need to edit your bus definitions to add the pin numbers. The final step is to deal with any constants or variables required by the additional code file. As an example, this SPI file needs values for these 2 constants to be defined in the test device file. XJDeveloper will add them for you automatically and will assign the default values shown, but you'll need to check those values suit the device you're using. When you add an additional code file from the XJTAG library that needs a configuration variable, XJDeveloper will automatically create it for you. You'll just need to click Edit Configuration to set the required value. While we're looking at additional code files, it's worth noting what's available in the XJTAG library because it has lots of files with useful functions. If you open the library browser and view the files by category, you'll be able to see what's there. Additional code files are identified by this icon. For instance, there's Oscillator, which contains functions that check if clock lines are toggling. In the Protocols category, you'll find files containing functions for communicating over buses, such as I2C and SPI. For I2C, the most commonly used function is checkPresent, which checks a device responds to its address. There's also Find Device, which scans all available addresses to discover which ones are being used, as well as functions for read and write. Then there's the Utility category. In there, you'll find additional code files like CRC, which has functions for calculating CRCs. There's also Data Reader, with functions for loading binary, hex, and S-record programming files. Functions in Math are for various useful mathematical operations, including things like check value in margin, which checks whether a value is within a specified margin of an expected value. And as you can see, there are plenty of other additional code files in the library as well, so it's definitely worth browsing through them to see what's available. If what you need doesn't already exist, you can create your own additional code file. This time, click Add and select New. Give it a name and save the blank file. You'll be returned to the Test Device Files screen, and your new file will be listed at the bottom. Double-click it to open the file in the editor and enter your code. If there's a file in the XJTAG library that's close to what you want, XJTAG encourages you to copy and paste functions from it into your own file and then edit them to meet your needs. License details can be found from the link at the top of the library files. When you come to write a test device file, you can call functions from the referenced additional code file. But don't forget what you heard in the third video about the scope of a function. In this accelerometer example, you can see how the checkPresent function from the I2C additional code file is being used to check the accelerometer is responding to its address. That's it for additional code files. The next thing to look at is the concept of configuration variables. They're a great way to define constants when their values depend on how the device is used in the circuit. The next video focuses on those, and you'll see how to set up a test device file to use them.